So now we're going to move on to geometric sequences. So last time we were talking about arithmetic sequences, which was when we were adding or subtracting the same number to go from term to term within a sequence. Now a geometric sequence is when the term can be found by multiplying the successive term always by the same number. Okay, so it's geometric when we're multiplying by the same number each time. Now, just like with our arithmetic sequences, we can write it recursively or explicitly or the nth term. Okay, so recursively, just like before, whenever we start with a recursive formula, we say a sub 1 equals whatever that number is. Okay, then we say a sub n is equal to r times a sub n minus 1, right? So I'm going to take that, whatever the common ratio is, r is what we're multiplying each time. What am I multiplying by each time to get this formula? Okay, now the nth term says that we do a sub n equals our first term times r to the power of n minus 1. Okay, so in our first example here, it says determine whether the following sequences are geometric. If so, then write the sequence recursively and as the nth term. So here, am I multiplying by the same thing each time? So here I'm multiplying by 4, multiplying by 4, multiplying by 4. So because I'm multiplying by 4 each time, this is going to be a geometric sequence. So now I'm going to write our formula recursively. So let's say what our A1 is. So A1 is 3, and because I'm multiplying by 4 each time, that means R is 4. So for recursively, we would say A1 equals 3. A sub n is equal to 4 times a to the n minus 1. So that's our recursive formula. Now our nth term, or explicitly, that formula would be a sub n is equal to a sub 1 times r, I don't know why I put r, so 4 to the n minus 1. So that's our nth term formula. A1 times r to the n minus 1. So in this problem, I want to figure out if this is geometric or not. So if I want to know if this is geometric, then I need to figure out if I divide, right? If I did 12 divided by 3, that gives me 4. If I do 48 divided by 12, that gives me 4. So I need to see if I did the next term and I divided it, would I get a number or would I still have a variable? So our first term here is negative 2 to the n. The next term in our sequence would be 2 to the negative n plus 1, right? That would be the next term in the sequence, which if I distributed that would give us 2 to the negative n minus 1. So these are our two sequences. So I need to divide these to see if I get a constant. So 2 to the negative n minus 1 over 2 to the negative n. Now remember, when I divide fractions, that means we subtract the exponent. So this turns into 2 to the negative n minus 1 minus negative n, which turns into addition. So our n's here cancel, and I'm left with negative 1. So 2 to the negative 1 is left, which we know negative exponents mean make it into a fraction. So that means our r is 1/2. And because I have just a number here and I don't have any variables left, that means yes, it is geometric. So it is geometric. So now I'm going to write it recursively. So we would say, well, what is a sub 1? Well, to figure out a sub 1, I have to plug in 1 to my formula. So if I plug in 1, 2 to the negative 1, that gives me 1/2. So our a sub 1 is 1/2. And our r just happens to also be 1/2. So then a sub n is equal to r times the term before it. Now our nth term formula would say a sub n is equal to a sub 1, which is 1/2, times r, which just happens to also be 1/2, to the n minus 1. So this is our explicit or nth term formula. Okay, I would like you guys to try example 3 on your own. Okay, so let's look at some examples of geometric sequences. So in this first problem here, it says given the geometric sequence, so I know it is geometric, I'm not testing it, I know it's geometric. Find the nth term of the geometric sequence, find the ninth term of the geometric sequence, and then find the recursive formula for the geometric sequence. So if I want to find the nth term, that's basically asking for our nth term formula, in which I need to know a sub 1 and a sub 2. R. So a sub 1 is 10. Now r is what am I multiplying by each time? So what did I have to multiply to go from 10 to 9? And then to go from 9 to 81 over 10? Well, if we can't think of that in our head, can't I just divide, right? If I did here, r would have been 12 divide 3, which gives us 4. Or r would have been 48 divide 12, which gives us 4, right? So we can always divide to find r. So I'm going to take our second term divided by our first term. That cannot simplify, so our r is 9 over 10. If I multiply 10 by 9 over 10, the 10's cancel and I'm left with 9. If I multiply 9 by 9 over 10, I get 81 over 10, right? So our r is 9 over 10. So our nth term formula is a sub n is equal to a sub 1, 10, times r to the n minus 1. Okay, B wants us to find the ninth term. So if I want to find the ninth term, that would be a sub 9. So 10 times 9 over 10 to the 9 minus 1. So that would be 10 times 9 over 10 to the 8th power. So 10 times 9 over 10 to the 8th power. That gives us this decimal, or as a fraction, it's not going to do that. To get a fraction, we probably have to start with a fraction. It won't write it as a fraction for us. So 4.305. All right, question C wants us, part C I should say, wants us to write it as a recursive formula. So our recursive formula says we state what A1 is, so A1 is 10. A sub n would be whatever r is, times a to the n minus 1. Okay, I would like you guys to try example 5 on your own. Check the answer on the answer key. Now, we can also find the sum of geometric sequences, right? So if I give us a sum here, we want to be able to find the sum of our geometric sequences. So our sum formula says we take a sub 1 times 1 minus r to the n over 1 minus r. So in this problem, if I want to find the sum, a sub 1 is equal to 1/3 times 1 minus r to the n over 1 minus r. Okay, so I need to figure out what r is. Well, if I look at my formula here, it looks like I'm multiplying by 2 each time. So our a sub 1 is 1/3 and the r is 2. I'm multiplying by 2 each time. So 2 to the n over 2. So s sub n is equal to 1/3 times 1 minus 2 to the n over -1. Let's just change that -1 to move to the front there. So it'll be -1/3 times 1 minus 2 to the n. So that's our sum formula. So what does this mean? That means if I said, for example, find the sum of the first, let's say 8 terms. Well, I cannot spell right now. Terms. Okay, then I would say, well, I want to find the sum of the first 8 terms. So I would do -1/3 times 1 minus 2 to the 8. So if I plugged that into my formula, -1/3 times 1 minus 2 to the 8th, I would get 85. So if I added up the first 8 terms of the sequence, I would get 85. That's what this formula is telling us. Okay, now number 7, same thing. We're going to have to figure out what is a sub 1, what is r, and then we're going to use our sum formula. So a sub 1 is a half. R, to go from here to here, here to here, I would be multiplying by a half each time. So our r is also a half. So to find our sum, we do a sub 1 times 1 minus r to the n over 1 minus r. That gives us 1/2 times 1 minus a half to the n over a half. Now remember, when I'm dividing by a fraction, that's multiplying by the reciprocal. So this is like saying 1/2 times 2 over 1 times 1 minus a half to the n, because this 1/2 became flip. Well, 1/2 times 2 over 1 is just 1, so that just leaves me with 1 minus a half to the n. Now, these formulas are for our finite sequences, right? So this is going to tell me the sum of something that's finite, right? The first 8 terms, the first 1,000 terms, the first 1,000,000 terms, okay? But there's a specific number that we're adding up, the first however many terms. Now, we also have infinite sequences, right? So if we have an infinite sum, meaning that it goes on forever. So if I have our sequence here and it goes on forever, we can actually still figure out what number it's going to add to, even though it's going on for infinity. These are called our infinite geometric series. And if we have an infinite geometric series, we have one of 2 things that could happen. If it converges, then that means that even though it's going on to infinity, we're going to be able to find the sum. So we can find the sum. Essentially what's happening is as we add, we're getting closer and closer and closer to a certain number. Okay, no matter how much I add on, we're going to be able to find the sum. If we cannot, then it's called a divergent series, meaning every time I add something on, it's not going to get us anywhere closer to what the sum is. So we're not going to be able to find the sum, okay, if it does not converge. So how do we tell if something converges or if something doesn't converge? Okay, so we can tell something converges if the r, the absolute value of r, is less than 1. So if it's less than 1, then that means it converges, and we can find the sum by using this formula here. So we're not going to use the sum formula from the previous page. We're going to use this new sum formula because it's an infinite series. Okay, so for example, determine if the following series converges or diverges. If it converges, find the sum. So if I want to know if it converges or diverges, I need to know what r is. So r in this problem is 2/3. I'm multiplying by 2/3 each time. I also know it's 2/3 because of this guy here. Now 2/3 is less than 1, which means it is going to converge. It's going to get closer and closer, even though this is going on to infinity. As I continue to multiply by 2/3 and add that, I'm still going to get closer and closer to one specific number. It's not just random. So to find the sum of our infinite series, we're going to do a sub 1, which is 2, over 1 minus r, which we said was 2/3. So that gives us 2 over 1/3. Remember, when we're dividing by a fraction, that means multiply by the reciprocal, which means no matter how many times I multiply by r, as this goes on to infinity, this number is going to get closer and closer and closer to 6. Kind of think about this like asymptotes, right? If I have an asymptote here and my graph is going like this, it's getting closer and closer and closer to 6. No matter how far to infinity I go, it's never going to cross 6. It's always just going to get closer and closer and closer to 6. That's that same concept. As I add on terms here, it's going to get closer and closer and closer to 6. But it's never going to change from 6. So it converges and the sum is 6, even though it goes to infinity. Okay, number 9. So this is kind of an example of that, but it wants us to use this concept to show that a repeating decimal 0.99999 is equal to 1. Okay, so I could rewrite this decimal as 0.9 plus 0.09, right? If I added those together, wouldn't that give me 0.99 plus 0.009 plus 0.0009 all the way on to infinity, right? Going on and on and on forever. That's the repeating decimal 0.9999999. So what does that mean for this series? That means a sub 1 is 0.9. And that means each time I'm multiplying by 0.1. So because this is less than 1, that means it's going to converge. And because it converged, I can find the sum of this infinite series. The sum formula tells us to do 0.9 over 1 minus 0.1, which is 0.9 divided by 0.9, which is 1. So that's why this decimal is equal to 1. I would like you guys to try example 10 on your own, determine if it converges or diverges, and then find the sum. Okay, last problem of the day. So we have a word problem. So initially the pendulum swings through an arc of 18 inches. On each successive swing, the arc is 0.98 of the previous length. So think of like we've got a little pendulum here. Maybe there's think of like a clock that swings. It's swinging, and each time it swings, it's going to be less. It's not going to go quite as far, right? It's swinging, and each time it goes less far. So it's saying that first arc is 18 inches. So to go from here all the way to here, that first time is 18 inches. And each time, the next time it swings, it's not going to quite get to 18. It's going to be 0.98 of the previous length. So what does that tell us? That tells us that a sub 1 of this is 18. And that each time after that, we're multiplying by 0.98, which means our R is 0.98. So in example A, it wants us to figure out what is the length on the 10th swing. So that's asking us to find a sub 10. Well, a sub 10 is going to be a sub 1 times R to the 10 minus 1 using our nth term formula. So that would be 18 times 0.98 to the 9, so 15.007 inches. B is asking us on which swing will the length of the arc first be less than 12. So I want to know when is it going to be less than 12. So I'm going to have to take my nth term formula, 18 times 0.98 to the n minus 1. I want to know when is that going to be less than 12. When is that going to happen? So first thing we have to do, divide by 18 on each side. 0.98 to the n minus 1 is less than, when that simplifies, it's 2/3. Now I'm going to have to use my log to get the n out of the exponent. So log of base 0.98 of 2/3, I need that to be less than n minus 1. To get that minus 1 away, we're going to add 1, and I'm going to plug that into my calculator. So remember, log base 0.98 of 2/3 plus 1 gives us 21.070 is less than n. So if I need it to be less than 12, I need n to be greater than 21, which means it would be on the 22nd swing. Okay, question C asks for, after 15 swings, what is the total distance the pendulum has swung? So I want to find the sum of the first 15 terms. And our sum formula, remember, is a sub 1 times 1 minus r to the n divided by 1 minus r. That's our sum formula. So I'm going to go ahead and plug that into my calculator. 18 times 1 minus 0.98 to the 15 over 1 minus 0.98, which gives us 235.288 inches. So after 15 swings, it's going to have moved a total of 235.288 inches, right, when we add up all of those swings together. Okay, lastly, question D here wants to know when it stops, what is the total distance it has swung? So that means that I want to know the sum going to infinity, because I don't know when it's going to stop, right? So we need to find the sum going to infinity, which means that it must converge. Let's double check. 0.98 is less than 1, which means it is going to converge, which means I am allowed to use this formula. So remember, this formula is a sub 1 over 1 minus r. That's going to give us to infinity. So 18 divided by 1 minus 0.98 gives us 900. So by the time it stops, it's going to have swung a total of 900 inches.